Solving multiple equations, known as systems of equations, is perhaps one of the most important and valuable tools you can develop as you prepare for your exam. Solving multiple equations usually involves isolating one variable and then plugging that answer into the second equation. In this case, they tell us that y is equal to -5. So I can rewrite my second equation as 5x plus 4 times -5 is equal to -20. Or 5x minus 20 is equal to -20. I can then add 20 to both sides, and I get 5x is equal to 0. Divide everything by 5, and I get x is equal to 0. And that's it. X is 0 and y is -5. These problems may look more challenging, but it's still the exact same process. We isolate one variable and then plug that answer into the second equation. Again, they've done us a huge favor by already isolating y. I know that y is equal to 4x minus 9. So I can take that answer and plug that into my second equation. So I can rewrite the second equation as 4x minus 9 is equal to x minus 3. Now my goal is to get x by itself on one side of the equation. So I'm going to try and get the x on the left and the numbers on the right. So I'll subtract x from both sides and add 9 to both sides. And I'm left with 3x is equal to positive 6. I divide everything by 3 and I get x is equal to 2. From there I can plug that 2 back into one of my original equations. So I can write the equation that y is actually equal to 2 minus 3, or y is equal to -1. And that's it. Y is -1, x is positive 2. In this problem set, they weren't nice enough to isolate a variable for us, so we're going to have to do that on our own. It doesn't matter whether you solve for x or y first. You simply want to look for whichever variable is the easiest to solve for. From here, I can see that adding y to both sides of my second equation will give me x by itself. So I can write the equation that x is equal to 13 plus y. From there, I can plug x into my first equation. So that equation becomes 4 times 13 plus y plus 2y is equal to 10. I distribute my 4 across the parentheses and I get 52 plus 4y plus 2y is equal to 10. I can combine my 4y and my 2y and then subtract 52 from both sides, and I get the equation that 6y is equal to -42. Divide everything by 6 and I get y is equal to -7. Now I can plug in -7 for y in either one of my first two equations. It doesn't matter which equation I use, I just want to choose the one that is the easiest to work with. So I'm going to choose the second equation and rewrite that as x minus -7 is equal to 13, or x plus 7 is equal to 13. Subtract 7 from both sides, and I get x is equal to 6. Every problem we've done up until now has been using what's known as the substitution method, where we solve for one variable and then plug that answer into the second equation. There is another method you should be familiar with, and that is linear addition, where you line up the equation much like you would an addition problem and add all of your variables and your numbers straight down. So in this case, I can add a -x and an x, a -y and a -3y, and an 8 and an 8. -x plus x, well, that equals 0. -y minus 3y, it's -4y, and 8 plus 8 is 16. I can divide everything by -4, and I get y is equal to -4. The only reason this really worked was because when we add them together, my x's canceled out. if the x's did not cancel out, all I would have done is create a new, more complicated equation, and it wouldn't have helped me solve either for x or y. That's why linear addition is not very useful most of the time. However, you will find problems on most exams, usually about one, not more than two, where linear addition is the preferred method to solve. So, don't use it a lot, just know it exists. And as before, the last step is to plug in my answer that I got for y into a previous equation. Again, I'm just choosing the simplest one I can find. So I will use the top equation. In this case, I get negative x minus a negative 4 is equal to 8. Or negative x plus 4 is equal to 8. Subtract 4 from both sides, and I get negative x is equal to 4, or x is equal to negative 4. The great thing about algebra is that there are many ways to solve a problem, and it really doesn't matter what you do as long as it's easy for you and you follow the rules of math. So I'm going to show you one more technique that, although may not be the exact easiest way to solve this problem for you, it's good to be aware of your options. In this case, I don't see any variables that I can easily isolate. But what I'm going to try and do is, instead of solving for y, I'm actually going to solve for 6y and then plug that into my second equation. So I can take my first equation and multiply everything by 2. So that equation becomes negative 4x plus 6y is equal to 30. Then I'm going to add 4x to both sides. So I get 6y is equal to 30 plus 4x. Now I can plug that answer for 6y into the 6y in my second equation. So that equation becomes negative 6x plus 30 plus 4x is equal to 18. I combine my x's and subtract 30 from both sides, and I get negative 2x is equal to negative 12. Or, dividing everything by negative 2, I get x is equal to 6. And from there, I simply take x is equal to 6 and plug that into the simplest equation that I can find, even if it's not an equation that was originally in the problem. As in this case, I see 6y equals 30 plus 4x. That's probably the simplest equation I can find with both an x and a y. So I can rewrite that equation as 6y is equal to 30 plus 4x, which in this case would be 24. Or 6y is equal to 54. Divide both sides by 6, and I get y is equal to 9.